All right, Mr. Spore here. Marine Biology, Weekly Species List, number 6, Mollusca, Part 2. All right, today we're going to be talking about a special little group of mollusks called the bivalves. And of course, you can fill out your weekly species list here. There are 6 this week, and we'll have some phylum notes as well, or in this case, some class notes, keeping it classy. And you can always go and study the Quizlet that I have linked up as well. That is an option. And let's just get this party started, shall we? Okay. So jumping off, first part will be the phylum notes, and then part 6, we have 6 in the list. Not a coincidence. I'm tricky like that. Okay, so in this phylum Mollusca, below phylum, you have class. So it goes kingdom, phylum, class, order, family, genus, species. So class we're talking about here is bivalea, or the bivalves, as we like to call them. They're a special group of mollusks. And by bivalve, we mean 2 valves. So mollusks that have 2 shells, 2 valves. Okay, and wrong direction. So these are organisms that have a mouth, that have a heart, that have an esophagus, but don't have a head. No head. No face. They literally have lips and no face. Think about that. Okay, and on the diagram here, if you have a look, so you got the little mouth right in here that they have. We'll explain that more. They take food in through that, and yeah, kind of interesting. Little tiny, call them a labial palp. And they swallow it down there, and then it goes basically right into their stomach, surrounded by some digestive glands, which would be like tissue that would secrete digestive fluids into the stomach area. This would be similar to like a liver or a pancreas, a little more evolved system. And then it travels through an intestine and then out through their little anus. Their anus is situated right above their mouth. Now, not really their mouth, sorry. Their incurrent and excurrent siphon, so where they suck in stuff from. So their mouth doesn't actually stick out of their body. Again, it's just a floating little pair of lips right next to a stomach hole. They really don't even have an esophagus in this case, because everything's kind of compacted and squished in there. So they suck in water through the incurrent siphon, and the incurrent siphon has little fringes on it, and so that if big particles come as they're sucking in water, kind of when they inhale through that, it kind of closes down and lets water through, but big, huge chunks like sand and rock won't get in there and gum up their works. They're sucking in water and they're trying to get at that plankton. So they suck it in, the water passes over their gills, and then travels basically, this is all kind of enclosed in a sac, and on the outside of that sac is a little mouth. And that little mouth, the labial palp, has mucousy stuff on it, and it grabs the phytoplankton, zooplankton, anything that's in there, passes it into the stomach where it's digested, and then it passes through their long little intestine, and then is pooped out next to their excurrent siphon, where they pump out all the water that once they've kind of filtered through that water as it's circulated inside of them around in here, and they pulled everything out, they'll squirt it out their excurrent siphon at the same time they'll poop, and those two kind of so good thing the anus is located next to the excurrent, and not the incurrent. Mollusks. Enough about their biology. There's about 10,000 species worldwide. That's quite a lot, and I put a link here just so you can get a kind of an idea of just the variety of mollusks out there. So the bivalve, and this is class Bivalea, but then they break them up into families, and there's a family index just showing you how many different families there are of bivalves. Here's all the family names, and then each of those is going to have a whole bunch. So Mytillidae is one of our species of this week will be Mytilus californianus, the mussels. So let's just look at mussels. Here's an example, and this is again just the family, and then here's all the genuses in there. So there's a whole bunch of different genuses within that, and then a whole ton of different species within that as well, making up that 10,000. So it's a really diverse group with a lot of different variations, as you can see here from this image. There's some really cool ones. I was looking at razor clams earlier in this one. So our razor clam, Siliqua patula, Pacific razor clam, this is the one that we have that we find washed up on our beaches. But look at this long one here. That's kind of a crazy. It's called the blunt jackknife razor. That's in a different genus, Solon, but they're still going to be all in the same family here, or actually two families classified up under a subfamily. And all of this falls under class bivalea. So within this class bivalea, there's 10,000 different species breaking off into different orders and families and in many different directions. It's a huge group. And 10,000 today, think about how many there have been throughout time itself. And we have a good record of these again because these kind of shells make for great fossils, right? This is a hard part that's already dug itself down into the sediment. I mean, it's literally like a fossil maker itself. It's really trying to be a fossil. And so clam fossils are really ubiquitous and common. We have a good record of them throughout the fossil record. You can really see their evolution. In fact, the first geologist, James Hutton, was a canal manager. He was the engineer that managed major canal systems throughout England in the 1700s. So where all the waterworks went and boating and stuff, and he kind of was the person in charge of that. He started mapping through the sediment layers the different mollusks that he found, and he found that there was a slow, gradual change in them over time, and that certain species were indicative of certain layers, and even though we didn't see them in other layers, they were indicative of certain layers of time. And he later went on and influenced a whole series of other geologists. It really started the science of geology itself. Kind of cool. Some of the world's oldest living animals are mollusks. The Atlantic clam, right? Arctica islandica lives to be 220 years old. That's old for an animal. And you may think, well, this has got to be awesome. Well, the name Arctica means that it's slow growing. Look at it. Nothing. Just a clam. Nothing special about it, but it lives in really cold water, so it grows really slow. Here you can see those siphons where it sucks in water and spits it out, and they got these little fringes around their siphons, again, to keep them from sucking in big things like chunks of sand and stuff. They want to just be sucking in. Well, I guess it's pretty good size there. Right? It's a handful. Whatever. Okay. Back to the presentation. Let's go. Okay. And biology, anatomy of these things. We kind of went through the digestive system there. I kind of pointed some things out. They also have these muscles that they use to close and open themselves, and they are called adductor muscles. There's an anterior, which would be near the head. Again, they don't have a head, so we say anterior because it's near the mouth. And posterior, because despite not having a head, they still have a butthole. And so posterior, right down here, near their posterior. So an posterior and anterior adductor muscle, and these are what they open and close with. These are the little pieces of white fleshy stuff that if you eat clams you really like, you kind of get in there with your teeth and try to get them out. And if you eat something, a mollusk like a scallop, actually in a scallop, you get rid of all the foot and other parts that we normally eat in a clam, and you only eat that adductor muscle. It's really strong and pronounced. Scallops are incredibly hard to get off rocks, but the adductor muscle is big and juicy. That's what holds the valves together. The mantle is the sheet of connective tissue that on a slug would be make up the shell that goes around it, kind of. And on these guys, it makes the shell too, I guess. On a snail, they have on a slug, I'm sorry, slug would be the skin. And on a snail, it secretes out calcium and hardens into a shell. And these guys, it hardens into calcium carbonate, which is like a bone-like shell. Calcium carbonate's what our bones are made of. It's what a lot of things are made of because it's two of the most abundant elements in the ocean. So you take those two most abundant elements in the ocean and you've got stuff to make stuff out of. So our vertebrate bones are made of them. Echinoderm shells and bones are, little spiny things are made of them, and so are mollusk pulps as well. So the mantle is this interior part that kind of surrounds all of this and that secretes out the stuff to make the shell. It has some sensory stuff in it too. The siphon is where they have an inhalant and an exhalant, or an in-current and an ex-current, where they take in water. Okay, they're filter feeders, so they pump in seawater through that siphon. The little blips take the food. We talked about that. I got ahead of myself. Excess food, non-food particles are blown out through the excurrent. The excurrent doesn't have any little filters on it because it's just trying to get stuff out, so it wants to get everything out. And they have a nervous system with numerous little sensors. So these are actually a pretty developed and advanced animal. In fact, when you look at their anatomy, this is more developed and advanced than a starfish or any really echinoderm, actually. Um, and yet, people get really butthurt if you were to eat a starfish, which would be disgusting, but a clam is fine. They're actually more complex biologically. They have light sensors in the edge of the mantle, so proto eyes, basic eyes, and these are a huge food source. Mollusks are the snack crackers of the sea. Everything kind of eats on them and preys on them, and they're down in the mud and sediment and lots of things. There are ducks, actually. Surf scotter is a type of sea duck that can swallow clams whole into its stomach, which is really muscular, and they also swallow rocks, and then they flex that stomach and they break them, and then they puke up the bits of shell and they digest them. That's pretty badass. Okay, our species this week. Let's get into them. First one is not a bivalve, but I had to get it in somewhere. Yeah, chiton are in their own separate class. So mollusca, and then you got your classes, bivalea, right? You've got your cephalopodia, and gastropoda would be the snails and stuff. And then I think just chitonota. I'm going to make that up, but it's something chitony. Makes up the chitons. Chitons all have these 8 hard plates that are on their back. They go back in the fossil record a long ways too, 500 million years. They've been around a long time. They got a really muscular foot, kind of like a funky group of snails that have been around a long time. And we have them commonly here. We have several species. A large one called the gumboot, a big red one, and the plates are covered up with the skin. You can find those in tide pools. This one's more common, but it blends in. You miss this one, and I would say that most rocks that I turn over out in a tide pool, half of them have this chitin on it. I mean, they're everywhere, but people miss them all the time because they just look like the rock. And until you point it out, they don't see them. They're only max 3 inches long. Many of them are smaller than an inch. And this one is called the hairy chiton. And let's say it together. Mopalia ciliata. The cili refers to the little hairs that run around them. They look like cilia or cilia, which are fleshy hair projections. We have them in our esophagus and in our throat and in our lungs. They're slow moving. They are herbivorous, and they grow all over the place. Okay, look at the pictures I have linked there. Pretty cool. One of my favorites are mussels. I love to eat them. They're delicious. They're abundant. They're everywhere, right? Mussel beds are, they're just like an ecological sort of community in and of themselves. They make up the major part of the mid-tide zone up and down the Pacific Northwest where there's rocks. You will find huge beds of, tens of thousands, hundreds of thousands, millions of mussels all aggregated there. You find them on jetties and things like that. They're a filter feeder. And each one is an individual. They can live a pretty long time too. I've seen some mussels that I'd estimate up to like 25 years old. Big. These guys, 10 inches long. I've seen them bigger than that. I've seen them well over a foot in Southern Oregon. And they link together with these little proteinous basal threads that grow out of the seam of them. And each hundreds or thousands of these little threads grow out and they anchor to the rock, they anchor to each other. So it's kind of like cables holding down a bigger structure. Picture a cell phone tower with multiple cables. And those cables have a little bit of give to them so that if there's swaying, if there's an earthquake, if there's any, wind, whatever, in this case, waves, right, hitting them, that if they move, they can kind of flex. Maybe one of these can break, but they have so many others that hold them in place. Now, that's each individual. Each individual is anchored to the rock and anchored to the individual next to him, meaning they form this extensive network where they all cooperatively anchor each other in. It's really hard to get one mussel off a rock. I often have to use a crowbar. When I go get them, that's what I do is I take a crowbar and I put it into a spot where I find a loose spot in there. I try not to damage any more than I'm going to eat, but I like to slide it right down there and just pop out a whole kind of chunk, rip it out. And I try to do it near an edge or not right in the middle where I'm going to create a weak spot for the entire community around and kind of leave them vulnerable. They are eaten by not just people, but by pretty much everything else. By sea stars, it's one of their main food sources. In fact, the bottom layer of the mussel bed is really determined by where starfish can predate on them heavily. And so that's usually like some point in the tide line. Starfish above where the mussels kind of live have a hard time getting up and staying up there in that hot, sunny area when the tide is out for part of the day. So the abiotic environment kind of determines the range of these things coupled with predation. And so it's one of those cool examples of multiple environmental factors. And with the sea star wasting disease that happened this past 10 years or so, the mussel communities really grew and spread into certain areas. And I know Oregon State University has been looking at, as the sea stars come back now, how are mussel beds shrinking and responding to that. Kind of cool stuff. Okay, and yeah, they're also used as knife blades and harpoon tips. They're shells, incredibly strong. Native Americans used them for a lot of stuff. Kind of cool to think about that being a harpoon tip. What would they be harpooning? Seals, most likely for food. Okay, another bivalve, our quintessential clam in this area is Nuttall's Cockle. You find these suckers everywhere, and these ones are pretty shallow. They can get to 5.5 inches, so pretty good size little biscuits. 34 to 38 strong ribs. They tend to be yellow-brown, and then the color kind of fades out towards palish towards the back. And they're real shallow. You can find these just on the surface. These are the ones that people rake for when they go clamming. And the way that I clam for these is to wear either barefoot or really soft neoprene slipovers, and I can feel them in the mud with your feet. And that's how Native Americans did it too. They would walk along and you feel a little hard nugget down in there in the really soft sediment when the tide is out, and then you dig with your hands and you can pull them right out. Better than raking. I feel like raking is just kind of like just tearing everything up. And this way you're kind of selectively looking for them. Okay, scientific name for this one is, we didn't even do California mussel. Scientific name for this one is Clinocardium nuttallii. Clinocardium nuttallii. The cardium part is obviously referring to something about heart. Maybe they're heart-shaped, or maybe they're, I don't know what. Nuttallii is referring to a famous naturalist, Nuttall. I'm trying to remember his first name. Anyways, a famous biologist. A lot of things are named after him as well. The Clino part, I'm not so sure about. I don't know if we covered this one, so let's go back over this name again. The California mussel's name is Mytilus californianus. Okay. Another one. This is a good one. It was really hard to select which bivalves we would do because we do have so many. And I encourage you, if you're into this, go out and get a shellfish guide and call them shellfish, not fish. It's a bivalve guide or a mollusk guide. That would be a better way to do it. And have fun, because there's a ton out there and you spend a lot of time identifying all the things you find. So I tried to pick just a few of the real big obvious ones, or the ones that we encounter the most, and ones that we eat the most or interact with. Pacific geoduck is not one that we see a lot of, but it is amazing and they're there. So the shell can be up to 9 inches, but the neck of this thing can't even fit inside the shell. These things can weigh up to 20 pounds. And you're thinking, what? These things are freaking huge. So this is a good one here. Look at that. And their adaptation is this. If you are going to be on everybody's menu, get bigger than anything wants to eat. Okay? So they bury themselves super deep, so they're really hard to get out, so you're not going to be able to grab one. And if they can't suck their neck in, their shell's going to go way down in there, and their neck is really long and tough. And if you try to grab at one, it will pull back down into the mud quite a ways. And then you're going to have to chase this monster down in there and try and dig it out. And it is a real art form trying to dig these suckers out. They are huge and massive. They usually are near the mouth of a bay, so there's a heavy current. I mean, look at the size of these things, right? Look at that. I want to find a picture. I have one here of there's that of boy. Okay, I gotta get out of here. Anyway, there's a picture of a guy digging one somewhere. I think I have it on my slideshow later on. They can live to be old, 168 years, and they're on the menu. People like them because they're cool and they're funny looking, and they're somewhat tasty. They're pretty tough, actually. Um, but they've been hammered. They've been hammered by over harvesting. They live a long time. They reproduce slow, and it's just the range has been shrunk. They've been eliminated from some bays and things like that. And I'm a person that even if people say they're farming them or whatever, which usually they're not, I don't eat them because I want to give them a chance. And there's plenty of other mollusks you can eat, you know, that won't garner as many laughs. Okay, two more for us here. Pacific. Oh, we didn't. Did we say this one? No, we didn't. Okay. Pacific geoduck. Scientific name Panopia abrupta. Panopia abrupta. Okay. There you go. Two more. We're out. Pacific Razor-Clam. This is Razor-Clams occur on beaches, not in bays or estuaries. So they're on your sandy littoral beaches, right in the wave zone. And when the tide goes out really far, a minus tide is the best time to get out and dig for these. You need a shovel. They can move pretty fast. They got a muscly foot that can dig down pretty quickly. So if they know that you're onto them, they'll dig themselves down deep in the sand there. They are delicious. And Native Americans, it was a major food source for these guys, harvesting these. They have been over harvested as well in a lot of areas, and people really go after them. And for that reason, I tend to leave them alone myself, but I think they're great. And harvesting is regulated. Just stay within your limits, please, with these. Because they occur on beaches, they can pick up a lot of that domotic acid that dinoflagellates put out. And there's a lot of closures around these, so you really want to check the time of year, what the situation is with the toxin levels in these, because these are the first to close and stay closed for a long time every year. So in the winter is the best time, usually never in the spring or summer. So like right now is probably a no-go or getting close to it. But delicious, often chopped up and fried into clam cakes. Scientific name is a very pretty sounding name. It's Siliqua patula. Sounds pretty to me. Siliqua patula. It's a fun one. Okay, last one. And again, we started with a non-bivalve. We're going to end with a non-bivalve in our whole section about bivalves. This one is a limpet. So this is a univalve. It has one shell, kind of comes up and makes a little peak. And there's a lot of limpets out there. There's a whole lot of limpets out there. But this is our probably most common one, and it has a huge range. It goes all the way up to Alaska and all the way down to North Mexico. We had this one up in the Aleutians where I worked. And they have a real strong, muscly foot on the bottom. If you flip them over, they're like a snail. They have a real pretty shell too. I mean, they were used for decoration a lot by Native Americans. You see them in a lot of woven like basket style hats, in necklaces and jewelry and ceremonial gear and things like that. I'm trying to find a picture here of one flipped over where you can see its muscly foot. They have two little antennae that stick out and a little raspy mouth. Oh, here's the muscly foot. So yeah, there's a muscly foot. This is where the mouth would stick out, and if it wasn't spooked right now, it'd have two little antennae sticking out here, kind of like a slug, where it would be feeling along. This foot is edible in a lot of limpets, so you could fry it up. Okay, one limpet? No, you want to get like a dozen of these. Chop them up with some butter and garlic, throw them in some pasta. They make an excellent fish bait, though. So if you're trying to catch things like rockfish, instead of using false, fake lures and other things, use the real deal. They like the smell, they love the taste. You can use I use a flathead screwdriver, pop these off rocks, scrape them out, hook them, and they stay on the hook forever because they're pretty tough. And cast that hook out there, and when I was in Alaska, the hook I would get a bite before it hit the bottom every time. Good stuff. They feed on algae, so they crawl along the rocks, and then when disturbed, they suck down, and they're really hard to get off rocks. Again, I used a flathead screwdriver to pop these suckers off. They're a favorite food of some shorebirds, such as black oyster catchers as well. In fact, a sign that oyster catchers are nesting or feeding in the area is just tons of dead limpet shells everywhere, especially if they have a chick. That's a good sign that there's some oyster catcher activity going on there. And yeah, they are good with pasta. Done it. Okay, so that's our species list for the week. Bivalea with a couple of oddballs thrown in there for you. Study those up. Lotia pelta, Siliqua patula, Panopia abrupta, Clinocardium Italiae, Mytilus californianus, and Mopalia ciliata. Ain't that silly? And of course, study up your some of these cool facts about bivalves. I put a lot of information on here, I know that, but it's cool stuff, and I couldn't just leave it at one slide. I had to make it two, okay? Because that's lit. You have yourself a good one, and ready for the quiz on Friday. Sapora out.